1. Oh, yeah, we'll have my favorite student. Oh, thing moved on me suddenly. Here, let's try this again. I'll walk through the whole question, then I'll break down the part marks. As usual, if you got the right answer and you showed some of your work, I'll give you full marks. If you just wrote down an answer, I'll get suspicious, because we're at a stage where I have trouble doing these in my head. I certainly wouldn't try doing these in my head on a quiz or a test. Looks like this question wants me to find that. I notice they gave me I say to myself, it seems to me if I could find the acceleration, then I could go d equals at squared over 2. What happened to the VIT? Okay. I could then say t equals 2 times d. I'm just doing this with my physics 11s right now. I'm just teaching them this formula and manipulation stuff, and their eyes are glazing over, and I'm trying to convince them it's a nice way to go when you wrap your brain around it. Hopefully I've sold you on it. Divided by a... Yes? I'm going to come back. I'll pause there. Now I'm going to find a. Okay. mg angles mg perpendicular, so we'll go components, mg parallel. Oh, there's going to be a normal force, same size as mg perpendicular, and then friction. Yep. And it looks like we're sliding. So which way is friction acting? Up. What if we were sliding up the slope? Down. Okay. If we were sliding up the slope, would there have to be an applied force? No. We're trying to get you to realize your velocity can be positive and you can have no forces in that direction. It just means you're going to slow down. By the way, the blue, that would be the free body diagram. If I asked for that on the test, hint, hint, wink, wink, nudge, nudge. The red dotted lines I wouldn't put on the free body diagram, but I add those to do the solving. But the blue forces, those 3 forces, those are the only 3 forces acting on this object. Now, who's winning? I'm pretty sure. Who's losing? Friction. And that equals ma. That's going to be mu times the normal force, ma. I don't know the normal force. Oh, but look. I know another force the same size as the normal force, ma. I think my m's are going to cancel, I suspect, because I think there's an m in everything. But you know what? I'll go one more line just to convince myself. Did I say line? 2 lines is sine. Minus mu mg perpendicular. Of course it is. And yeah, look at that. Why can I cancel out the mass? Because there's a mass in every single term. If one of those was missing a mass, I'm out of luck. You won't be able to cancel out the mass on most lawnmower questions. Trust me. Okay. So A is going to be 9.8 sine, what did I say theta was? 53, pretty steep hill. Minus, what's mu? I don't know, what's mu with you? 0.44 times 9.8 cos 53. Cool. A equals point go? There it is. 8 times the cos of 53. And I get 5. Since this isn't my final answer, I'm going to carry some extra sig figs. I'll go 5.2316. Since there's a lovely 0 right there, that's a nice place to stop. And I'm going to go trundling off to here. I said, okay, 2 times 4.8 divided by 5.2316, although I'm going to use my answer button because I can. 2 times 4.8 divided by answer button, square root of that, and I get 1.35 seconds. I'd take 1.34, 1.36, but yeah. If you got that, what's this worth? 4 out of 4. I would make this a 7 marker on the test, by the way, but 4 out of 4. Otherwise, how the heck would I give out part marks for this? Good gosh, I got to zoom out a little bit. Let's see here, Mr. Duick. I would give you 1 mark if I saw t equals the square root of 2d over a. I would give you a half mark for that answer. That's 1.5. That gives me 2.5 to play with. I would give you 1 whole mark if I saw mg parallel minus friction equals ma. That's 2.5 marks. I would almost certainly give you a half mark if I saw that. I would give you a half mark if I saw that, and a half mark for the answer. Probably something like that, I think. But if you got the right answer, 2 out of 2. If you're not sure, lawyer with me afterwards. Mr. Dewitt. Yeah, Jason. Your acceleration, 5.2316? Yeah, what about it? Mr. Dewitt, are we, oh, wait a minute. Are we speeding up or slowing down? Oh, we are speeding up. So I don't need to make the acceleration negative. I was worried for a second there. But wait a minute, we're starting at rest. So it must have just started to slide down the hill on its own. So it is speeding up, so it should be a positive acceleration. Cool. Then I'll take that one to the bank and I'll go to the next question. Atwood machine. Find the tension in the rope. I'm going to find the tension by using the mass that I know. The mass that I know is this one here, M1G. Tension. If I was drawing the free body diagram, by the way, would I draw tension bigger or smaller than mg? Kyle. Why? You're right. Which way is m1 accelerating? So what must be bigger? Gotta be. Okay, now I can write an equation. Who's winning? Who's losing? M1G, and that equals M1A. I know all of those except for tension. I'll get the tension by itself. Tension is going to be M1G plus M1A, or M1A plus M1G. It's going to be 5.9 times 9.8 plus 5.9 times 3.6. 79.06. I'll write 79.1, 3 sig figs. 71, Mr. Duick, nice try. 79.1 newtons. That gets you 2 out of 2. Otherwise, I would give you 1 mark for that, half mark for that, and a half mark for the answer. But if you got the right answer, 2 out of 2. B. Is B find the mass? Mass 2? Is that what it is? Well, you know what? I'm probably going to need to draw the forces on mass 2. What are the forces on? Get the okay. M2G. Tension. I made tension shorter than M2 because I'm pretty sure in this case, who's winning? Kohei, you going to make it? You look a little tired. That was a long blink. You awake?
Yeah.
You're not. Manny, we need your help again. Here we go. So I think my equation is going to be M2G minus tension equals M2A, and I'm trying to find M2. Oh, how many M2s are there? How many would I prefer? Let's get them to the same side. Are you seeing? We've seen this a little before, yeah? It's going to be M2G minus M2A equals tension. How many M2s are there? 2. How many would I prefer? 1. It'd be wonderful if there was some kind of a little grade 9 operation that I could pull out of my back pocket. Oh, there is one, you say? Factoring. I can factor this into M2G minus A equals tension. Oh, I should say one more thing, Dustin. Do the masses cancel here? There's a mass here. Is there a mass in the tension? So don't be thinking the masses cancel. Besides, if they did, what would I find? Because I'm trying to find the mass. I don't want it to cancel. So if I hear you, Dustin, correctly, and I think I do, you're telling me M2 is going to be the tension divided by G minus A, which is going to be 79.06 divided by 9.8, take away, what was A, 3.6? Okay. You get 12.75 ones. I'll go 12.8, I guess. And kilograms. For 2 marks, I give you 1 mark for that. I give you 1 mark. No, I can't give you 1. Did I give you 2 marks for this? Oh, I can't give the 2 marks the way I want. Okay. I guess you know what? I'd give you a half mark for that. To me, the big leap is this factoring trick right there for cluing in that you can factor. That's the key to doing the question. So I'd probably do something like that. That's what I would want to reward. That, I can change it from 2 into 1 variable. I saw a number of you left this blank. By the end of this question, hopefully you'll go, really? So you're, a student of mass M places a bathroom scale on a skateboard. He then rolls forward on level ground while standing on the scale. So really this is asking what happens to the normal force. What will the scale read if you're rolling on a level ground skateboard? If you're rolling on a skateboard on level ground, what will the normal force read? I think just straight mg, or since it's in kilograms, the mass. 1 mark. Down a ramp, what will the scale read? More than m, less than m, or m? Convince me. Now, I'll take a number of possible solutions, but I think here is what I would do. I would probably bring out a good diagram. And I would probably say something like, what are the forces acting on this skateboarder? Get the obvious one. I would probably then go and mention that this is mg perpendicular, mg parallel. Kohei, have I used any English yet so far? Have I written any English in my answers so far? Say no. No. So far, so good. Oh, which force am I missing? Okay. Then I would probably say something like this. I would have to write a little bit of English. Scale reads normal force. I think it's worth mentioning that. Now, if you didn't, show me yours and I'll probably still take it. But I should point out to the marker, I'm going to be talking about the normal force for the rest of this question instead of the scale. Right? I don't know the normal force. Oh, but look, 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 look. Right? But what is perpendicular? Which trig function? Of course it is. When you're level, what's theta if there is no ramp? 0. So that would be m, you know what the cosine of 0 is? It turns out it's 1. When you're level, don't write this down. mg, that's what you did last year in Physics 11 all the time. And that's why some of you got in the habit of saying friction equals mu mg, and I've had to yell at you. No, it's mu times the normal force. I don't know the normal force. Look, 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 look. And I guess as soon as cosine isn't, as soon as theta isn't 0, 5 degrees, 10 degrees, this is always a decimal, less than 1. If you're multiplying by something less than 1, you're going to be a smaller answer every time. Now, I'm not going to make you write out that conclusion. I would just say, therefore, normal force is always going to be smaller than. I'd take something like that. Now, if you made up numbers and you simply showed, so, oh, I'll make the skateboarder weigh 60 kilograms. I'll make theta 10 degree, and you showed that normally 60 times 9.8 is whatever, and then you showed that the new normal force is 60 times 9.8 times the cos of 10, it's just smaller. I'd take that as well. And if you're not sure, show me later. Number 4, assume no friction. Yay! Because what do they ask me to find here? Oh, you know what? Did they give me both masses? Then I'm going to do a big diagram, and winner minus loser equals m both times a. What are the forces acting because on mass 1? Get the obvious one. I like that. What else? Yep. Is there a normal force on mass 1? It's not touching the ground. Is it?
No,
Is it touching the wall? Nope. So there's no surface pushing on it? Nope. That's it. What are the forces acting on mass 2? Guys? Shh, sorry, a little quieter. What are the forces acting on mass 2? Get the obvious one. I'll call it m2g. And I'll break that one up into perpendicular and parallel. What else, Vikas? I totally agree. What else? Which is going to be the same size but perpendicular, opposite to mg perpendicular. You know what? I'll call it normal force number 2 just to go with mass number 2, even though there isn't a normal force number 1. I'll just be consistent in my numbering. Friction? No. Okay. If this hill is made of ice, no friction. Who's winning? Well, it would depend, although, wait a minute. What is mass 1, Vikas? What is mass 2? You know what? If this was 11 and this was 7.8, it might be winning. But the fact that this is the heaviest mass and this is on an angle, I'm telling you, that's if you run the numbers, that's going to be the winner. So my equation is going to look like this. M1G minus tension plus tension minus M2G parallel equals that. Clay, are you relaxed? Why?
I'm losing tension.
Yeah. The only people that shouldn't be relaxed are people that didn't do the quiz. Gotta be paying attention, kiddo. And you know what? I'm gonna get the A by itself already. I think it's gonna be divide M1 plus M2, and it's gonna be M1G take away M2G sine, what was theta, 36? So now I can plug and chug. The acceleration equals, what was M1? 11 times 9.8 minus 7.8 times 9.8 cos 36. Cos, Mr. Dewick? Sine? Of course it is. No, sine, Mr. Dewick. All over. I'm getting old, Clay. I'm getting old.
Well, I wouldn't say that.
The mind goes, hair goes next, the eyes go third. So as soon as you see that, 7.8, not 9.8, Mr. Dewick. 9.8 is the acceleration. Good catch. 11 times 9.8, that's right, minus 7.8 times 9.8 times sine 36, close off the sine, and I have to then close off the bracket, divided by 11 plus 7.8, not 9.8, Mr. Dewick. Do y'all get an acceleration of 3.34, that? I'm going to write 3.34, but I have a feeling I'm going to use this. I'll hang on to it on my calculator. I would give you half mark for that, 1 whole mark for that, and then a half mark for the answer. To me, getting to the equation is the key in my mind. Find the tension. Which mass would I be cleverer to use to find tension? I'm going to go mass 1. Even though tension's a loser, it's a much nicer, no trig, right? So I'm going to go, you want tension? Okay, I'll give you tension. M1G minus tension equals M1A. Oh yeah, we've seen this dance before. That goes there, that goes there. It's not that much extra work if tension is a loser. It beats doing all the trig. I'm going to get tension equals M1G minus M1A. It's going to be 11 times 9.8 minus 11 times 3.34, but I'm going to use my answer button. Don't be a meathead, Manny. Help them learn. Don't be a distraction. I gave it to you in trust. With great power comes great responsibility. Do you get 71.0 newtons? I'd probably go half mark for that, 1 mark for that, half mark for the answer. What would the minimum coefficient of friction need to be between mass 2 and their open order to hold the entire system stationary? So now I'm going to go back, and I'm going to say, okay, apparently we also now are going to add friction. I'll call it friction force number 2 to go with mass number 2. Okay. Well, looks like it would be winner minus tension plus tension minus M2G parallel minus friction, and that's going to equal 0 because it's stationary. Is that okay? I'm going to plus this to this side. Oh, and I'm going to relax. So I'm going to get M1G minus M2G sine theta equals mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force, M2G perpendicular. I'm going to go M1G minus M2G sine theta equals mu M2G cos, perpendicular. Of course it is, theta. By the way, is there an M2 in everything? No, you might be tempted to cancel out the mass because you might see an M in everything, but one's a mass 1, the others are mass 2s, so they don't. What am I trying to find? What's mu? I don't know. What's mu with you? How would I get the mu by itself? Yeah, this looked ugly, but it turned out not to be too bad. Mu is going to be M1G minus M2G sine, all divided by M2G cos. M1, 11 times 9.8 minus 7.8 times 9.8 cosine, what was the angle, Mr. Dewick? 36? Sorry, not cosine, sine 36. I did it again. Of course I did. All divided by 7.8. Oh, I just noticed I was too focused on the question. I could have, though, done this, because there is a G in everything. Could have. Didn't catch it right away because I was too into the problem. But I could, if I wanted to, Dale, go 9.8 cancel, 9.8 cancel, because there is a 9.8 in everything over there. In fact, really, I could have done it on this line. Kev, look up for a sec. Sorry, Dale, look up. I could have gone boom, boom, boom. Okay. I did extra writing. I hate doing that. What's mu? I don't know. What's mu with you? Mu ends up being bracket 11 minus 7.8 sine 36 divided by bracket 7.8 cos 36. Ooh, typo. Good thing I caught it. 11 minus 7.8 sine 36. Close off the sine, close off the top. 7.8 cos. Okay. Do you get 1.01? 1.02. Yeah? Really, what does that mean? The fact that it's bigger than 1 says you need some glue. That's if you want to know a definition of a coefficient of friction bigger than 1. It's got to be really sticky because that 11 is really winning. That 11 kilograms is really winning. But okay. 1.02 what? Good, no units. If you got that, 2 out of 2. Otherwise, I'd probably give you 1 mark if I... let's change colors, Mr. Dewick. Let's go to blue. Let's go to green. I'd give you 1 mark if I saw that. I'd give you a half mark for that and a half mark for the answer. 2 more. And then we got some more of those Shaolin Monk videos to watch. Oh, yeah, I got more. Hey, what's number 5 asking me to find? What's mu? I don't know. What's mu with you? Okay. Got a ramp. Skier. Here we go. mg down, and I'm going to break that up into mg perpendicular, and running out of room here, mg parallel, right there. There's the 90. There's a normal force, because you don't sink into the ground like... That's terrible, Mr. Dewick. Because you don't sink into the ground like quicksand. Which way would friction be? Up the ramp or down the ramp? Up. I drew friction pretty short because I think snow is... In fact, I'm hoping if I made these numbers up reasonably, hopefully we get a fairly small mu. We might not because I was just making the numbers up, but hopefully it works. Who's winning? Who's losing? That equals MA. That's going to be mg parallel minus mu times the normal force equals ma. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. It's going to be mg parallel minus mu mg perpendicular equals ma. Oh, hey, cool. This time I spotted it. What are we trying to find? Okay. Here's what I'm going to do. What's right in front of the mu right now? No, right in front of the mu right now. Something I don't like to deal with. Negative. So I'm going to, you don't have to, so your work might look different from here on in, but I'm going to plus this to this side and minus the a to this side. I'm going to write this as g parallel minus a equals mu g perpendicular, because I think that looks prettier. If you didn't, you'll end up dividing by a negative later on, I think, somewhere along the way, which is also fine. How would I get the mu by itself? Hello? How would I get the mu by itself? Divide by g. Okay, so I'm going to get this. Mu equals g parallel minus a all over g perpendicular. So if I hear you correctly, Clay, you're saying mu is going to be g, 2 lines is sine. How big was the angle? 16. Minus a all over g cos 16. Oh, rats. What don't I know? So even though this question said find what's mu, I don't know what's mu with you. What am I actually going to spend a fair chunk of my... What's it really asking me to find? I hope... Now, I can't find acceleration using forces. Maybe unit 1. Maybe I can defic. You know what? Let's go see. Oh. Cool. Oh, this is good. This is good. This is good. Oh! I can do that. This is, in fact, this is physics 11, isn't it? It's VF equals VI plus 8. Oh, it's A equals VF minus VI over T equals 20 minus 0 over 8. 20 divided by 8 is 10 divided by 4 is 5 divided by 2.5. Is that right? Yep. And let's bring that back over to here. So it's going to be 9.8 sine 16 minus 2.5 all divided by 9.8 cos 16. Mr. Dewick, why didn't you cancel out the g's? Is there a g in everything? Then I can't. Let's see if this works. We get 0.0213, 0.021, 0.0214, which is a small coefficient of friction, which it's snow. That at least also means Mr. Dewick tried to make reasonable numbers. Is that okay, Dustin? Thumbs up. So I'm gonna go 0.0214. Or 2.14 times 10 to the negative 2, if you wanted to do it in scientific notation. Units, nothing. So if you got that, 4 out of 4. Otherwise, whew, I would give you a half mark for finding the acceleration, but that's physics 11. I would probably give you half mark for that. That's 1 whole mark. I would give you 1 whole mark if I saw you're able to get the mu by itself, and then I'd probably give you a half mark for the sticking in the numbers. Let's see, what's that? 1, 2, oh no, I got more to play with. 1 mark, 2 marks. Oh, this is good. I would probably then, what would I do? What would I do, Mr. Dewick? I'd probably give you a half mark for that. Oh, and a half mark for the answer. How about I do that? 1, 1.5, 2.5, 3, 3.5. I'm still a half mark short. Maybe I'd give you a half mark for cluing that in. I don't know. Something like that. Example 6. There's the key to solving this question. I'm going to do a free body diagram, or I'm going to label my forces. Oh, no, they want me to, you know what? Since they said draw a free body diagram, okay. What are the forces acting? Get the obvious one. Gravity. There's an applied force. Why would this be wrong? Because it is. For the normal force. Okay, I'm going to be fussy. I'm going to insist that your normal force arrow is shorter. What else? Friction. And I tried to draw friction about the same line as what same length as what Fx would be. How many arrows did I draw? 4. How many marks is this worth? So what, you're saying a half mark per arrow? Sure. That's how I'd mark this. Now, if you did this, I would take a half mark off. If you did it with dotted lines, I'm okay with that, because a dotted line says that's a component. It's not actually on the diagram. If you did this, then, that I'd be okay with. But I think I'm actually going to go label my picture now, too. I'm going to say, okay, Fx, Fy, friction. Friction should be red because it's not a component. Mr. Dewick, be consistent. Cool. Calculate the force of friction. See, normally I'd go like this. And then I'd say, I don't know, normal force. And we'd go, look, 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 look. But I need mu. Did they tell me the coefficient of friction? Max says no. So, you know what? I've got to find friction indirectly. Oh, let's write an equation. Horizontally, who's winning? It's a tie. A is 0. So, Kyle, here's what I would do. I would say, it turns out Fx equals friction, which also makes sense because how many marks is this worth? 2, not a whole bunch. Shouldn't be like a bunch of work to get there. Because what's Fx? I think Fx is the applied force times the cosine of the angle. I think friction is going to be the applied force, 140, times the cosine of 28. I think friction is going to be 123.61. I'm going to write 124, but I'll keep this on my calculator. I would probably give you 1 mark for that, half mark for that, half mark for the answer. C says calculate the normal force. I don't know the normal force. Oh, but look, 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 look. I know, a bunch of other forces that I can use to figure out the normal force. I think everything straight up equals everything straight down, right? So I think I can say this. Gravity equals normal force and Fy. Or I can say normal force equals gravity take away Fy. Normal force equals gravity, mg, take away Fy, opposite, oh, you know what? Sine 140, sine 28. I think the normal force, come on, is going to be m. What was m? Oh, 55. Doesn't cancel this time. 55 times 9.8 minus 140 sine 28. Do y'all get a normal force of 473.27? I'll write 473 newtons. Same as before, I'd give you 1 mark for that, half mark for that, half mark for the answer. D, how many marks is D worth? 1, which means probably it's not much work. Oh, you know what? Friction equals mu times the normal force. I guess mu is friction divided by the normal force. I found friction in part 1. Divided by, I found the normal force in part 2, or part B and part C. I've rounded off, instead of me writing 124, I'm going to go 140 cos 28, because that's what friction was. Divided by, but now I can go, haha, answer button, because I got that one stored. Do you get a mu of about 0.26? 1.86? I'll go 0.261. And I'd take, 0.258, 0.259, somewhere in that range. No units. I would probably go 1 mark for that, half mark for the numbers, half mark for the answer.